Hello everyone, welcome to my channel. So in this video, I want to continue our topics of probability. So now, in last videos, we already talked about the probability density function and cumulative distribution function of continuous random variable. So in this video, I want to talk about two important terminology, mean and variance of continuous random variable. So in previous, we already give the definition of what is a mean and what is a variance. Mean is a weighted average of our random variable of all of the possible values. And variance is a way to describe the spread of the possible values of our random variable. So for the continuous random variable, because this variables is between an interval, so that means a little different with the mean of discrete random variable, which is the sum up of the possible value of random variables times the corresponding probabilities. The mean of the continuous random variable is defined as an interval. So you can see if we denoted our continuous random variable as capital X, then the mean, or we also call this expected value of our continuous random variable X, is an interval from negative infinity to positive infinity of the X times Fx of integral of this with respect to X. So here, this fx, of course, is our PDF, the probability density function of our random variable x. So this is the definition of our variance. And then what is the definition of the variance of a continuous random variable? So in the discrete random variable, the variance is defined as the mean of the difference of our x, all possible values of our x and the mean, and take a square. So the similar idea for our continuous random variable. So it's also defined as the mean of our square of the difference between x and the mean. And here, because the mean of our continuous random variable is defined as interval, so that's why we can have the formula of the continuous random variable look like this. Okay, so in the previous video, when I introduced the variance of a discrete random variable, I explained how we can rewrite the equation like here, what we have in the second line to the third line. So in this video, I will also explain how we can write the second equation to the last line equation. So the idea is also similar. The first step is also we use the distribution function of the multiplication to compute the x minus mu square to this following equation. And then the next step is we also use the discrete formulas of the parentheses and multiplication to compute the and also remove the constant term from this intersection to outside. So here, because the 2 and also mu, which means the mean of our random variable, they are all constant value. So that's why we will have the formula will look like this. Okay, so then if we compare this with our properties and also the properties of probability and the definition of the mean of a continuous random variable, we will find the second term, actually this is equal our mean. So here I denote this by mu. And then the third term, this is just the integral of our PDF from negative infinity to positive infinity. So this one we will get this is equal 1, right? This is by the axiom of the probability. And so when we have this, we can rewrite our formula looks like this. So here we will find the second and third term. Actually, this will cancel one of mean with each other. So in other words, in this equation, what we will left? We will left the first term of this formula and minus the square of mean. So if you compare this with the third line of our definition, you will find they are exactly same with each other. Okay, so this is how we can rewrite, or in other words, how we have two formula to compute the mean of the variance of our continuous random variable. So similarly with the previous topics, we also have a definition of the standard deviation. So standard deviation of a continuous random variable is defined as the square root of our variance. So here the formula is a sigma, which is our standard deviation, is equal to the square root of our variance denoted by sigma square. Okay, so this is an example of our question. This is a definition of our three terminologies: the mean, all expected values, variance, and standard deviation. So now let me give you one example of these topics. So here, this is example. If we have x is a continuous random variable, and also this continuous random variable has this probability density function, and then the question is what is the mean, what is the variance, and what is the standard deviation. So to compute this one, we will just need to use our definition of this mean and variance and standard deviation. So by the definition, the mean of our continuous random variable x is integral of x times dx, and derivative is with respect to x. However, because if you look at our definition of this PDF, you will find this actually is divided to three. This is a step function, and they have divided to three branches. So we will find if x is smaller than 0, it's always equal to 0. And when x is between 0 and 25, the value of our PDF is 0.04. And when x value is larger than 25, this function will equal 0 again. So then here, by this definition of our PDF, when we want to plug in this into our definition of mean, we will find this integral from negative infinity to positive infinity will divide it to three branch. So this three branch is decided by our definition of PDF. So when this is smaller than 0, this is just x times 0, right? And then when it's between 0 and 25, this is x times 0.04. And then when this is larger than 25, this becomes x times 0 again. So then by our property, we will know the first term and also the third term. Both of this is always equal to 0 because the function we integral here is actually 0. So by this one, the question will become just integral from 0 to 25 and 0.04x dx. So now we will need our information or knowledge of calculus. So to compute this by our integral of the calculus, we'll find this is equal this equation. Okay, so now if we have this equation, then after the computing, we will get the answer of this question is equal 12.5. Okay, so this is the answer for this part, and this is how we can compute the mean or expected value of our continuous random variable. And then also we can also compute what is a variance. So by the definition, we know the variance is equal integral of our x minus mu, or the mean, and then take a square divided by x. And we also have another way to compute this is x squared fx, take this integral minus the square of our mu, which is mean. So we have two ways to compute this. And then, so here what I will use is I will use the first one. Let me see. I will use the second one. So to compute this one, I will by our knowledge of calculus, actually this is equal an integral from 0 to 25 x squared times a 0.04 x squared dx and minus square of our 12.5. So then by your calculator's knowledge, we know this is look like this equation. So because the integral of x squared is equal x cubed over 3, right? So now when we plug in the upper and the lower limit here to this function, and we can get the final answer of our variance is equal 52.08. So this is our values of variance. Okay, and the last step is how we can compute the standard deviation. So standard deviation will equal the square root of our variance, right? So this means it's equal the square root of 25.8. And by the calculator, we can get this will equal 7.217. Okay, so this is how we can define the variance the mean variance standard deviation of a continuous random variable. And I also give an example of this one. So before the end of our this video, I want to give you one more thing about the mean and variance. So if we have a mean of variance, right, we already know for a mean of variance, they will have a property of mean and variance. So here, so that is a linear relationship of mean and variance. We talk this when we have a discrete random variable. And for a continuous random variable, we also have a similar properties. So here, let me write down this. So here, if we have x is a continuous random variable with a PDF probability density function denoted by small fx, and we have h is also a function, then we can have this property. So the mean of our hx is denoted or defined as an integral from negative infinity to positive infinity of hx times fx dx. Okay, so here for the example of our hx, it can be many examples. So it could be some function like hx is equal like 3x plus 4, which is here this 3 and 4 actually can be changed to any constant number, right? So we can also denote this by the a and b. So a, b here are constant. So this is just one example of how to compute this, or how to define this hx. So there are much more examples about this part. But in this one, you can find a lot of examples about this. So, okay, so this property will help us to compute some translate or some rewrite x, and in this one. So if we have get a value of what is mean of x, then if you think about what's the mean of 3x, actually you don't need to compute this integral again, because when hx is equal 3x, then that means here we just plug in 3x in this integral, and then by the linearity property of our integral here, we know this it just means we move this 3 outside of this integral. So this will become 3 times the interval, this integral from the negative infinity to positive infinity of x times fx. So that will become 3 times the mean of our x. So that means the mean of 3x is equal 3 times the mean of x. Okay, so this is my video of the mean and variance of a continuous random variable. So in next video, I will start to give some important examples of continuous distribution and continuous random variable. So hopefully I can see you in next video, and please subscribe my channel.